In this video, we're going to talk about imaginary numbers. So before starting this session, you should understand the basics of square roots, how to simplify square roots, and how to solve equations with square roots. So pretty much anything involving square roots you need to know before you talk about imaginary numbers. All right, so far, if we had an equation that involved a negative square root, we would have said there's no solution. So if we had the equation x squared equals -1, we would try to take the square root of both sides, and we'll get x equals plus or minus the square root of -1. But that square root of -1 doesn't make sense. All right, so we would just said that's not possible and there's no solution. And that's true that there's no solution when we're talking about real numbers. However, there's another set of numbers we can include, and that's the complex or imaginary numbers. So both names are kind of goofy. Complex makes them sound really difficult. Imaginary makes it sound like they don't exist. And in both ways, those are kind of true, but they're just ways to allow us to expand the number of possible solutions we're going to have to quadratic equations or any equation where we have to take a square root. And it seems weird that we kind of have to make this up in a sense, but there are actual applications where using imaginary numbers helps to expand the field. So in order to create these complex numbers, we only need to introduce one thing, and we just need to make sense of what is the square root of -1. We just said if this was like x equals square root of -1, we'd have no solution, but we want there to be a solution. So now we're just going to give it a name. So we're just going to call it I. All right, so I now, just like pi is always 3.1415, and so on. Pi always represents this number. I always represents the square root of -1. And by just introducing this one thing, we get every possible quadratic has a solution now if we include these complex or imaginary numbers. All right, so let's simplify this expression, the square root of -4. This wasn't something we can do before, but we just recognize -4. We can kind of separate the -1 apart from the 4. And we just take these two square roots separately. The square root of -1 is this thing called I, and the square root of 4 is 2. And generally we write, just like we would do with the x's, we'll write the number in front, so I would write this as 2i. All right, that is the square root of -4. All right, it requires this imaginary number, but now we can actually write it out without a square root. Square root of -27, we can't take the square root of 27, but we will still separate it out into the -1 part and the 27 part. But also remember, we know how to simplify square roots. If we think about our perfect squares, all those numbers and so on, if those divide our number in the square root, we want to keep simplifying. And in this case, 27 is 9 times 3. So some of these numbers are going to behave nicely with the square root and some are not. So the square root of -1, that's that I we were talking about. The square root of 9 is 3 because it's a perfect square. And that last 3 that's in here, we can't take its square root because it's not a perfect square. So you can write it like that. You might also see it written like this. Generally, I like to write square roots at the back because it's not always obvious if I was supposed to extend this line here or not, which I don't want to. So generally, I would probably write that like that. All right, so here's one for you to try on your own. Fully simplify the square root of -50. All right, I'll show you the solution in 3, 2, 1. And the fully simplified version is 5i times the square root of 2. So now when we're solving an equation that involves these negative square roots, we don't just stop and say there's no solution. We're going to keep going, and our answer will just have an I in the final answer. So if we want to solve this equation, we learned how to solve equations with square roots before. The main strategy is the first thing you want to take whatever's being squared and get that by itself. So to do that, the first step I'm going to do in this problem is subtract 9 from both sides. And now that I have that thing being squared by itself, I can cancel out the square with a square root, all right? Because a square and a square root are opposites, they cancel out. All right, remember whenever you take the square root of something, or square root of an equation, you get this plus or minus the square root of -9. And if you think about what we just did in those last examples, the square root of -9 is going to be 3i. The negative turns into the I, and the 9, the square root, turns into a 3. Now the last step, I want to get x all by itself, so now I had to subtract 3 from both sides. And -3 and 3i are not like terms, just like if it was 3 plus 3x. You can't combine those because they don't have the same things. All right, same thing with the 3 and the 3i, we can't combine, so we're just going to write our answer like this. the -3 part that we subtracted from the right, and that plus or minus 3i part that we had from the square root. And that'll be our final answer. All right, so I'll do one more example, but very similar to the last one. We have this thing being squared, so we want to get that by itself. We do addition and subtraction first. So the first thing I'm going to do is subtract 4 from both sides. And now I need to get rid of that 2 on the outside. So I'm going to divide everything by 2 because it's being multiplied, the thing being squared. And now that I have the thing being squared by itself, I take the square root of both sides. Again, the square root and the squared cancel out. On the right-hand side, I took the square root, so I'm going to put a plus or minus. And a square root of -1, that's actually just the definition of I. So there's no extra number, it's just I. And lastly, get rid of that other thing next to the x. We have x equals 2 plus or minus I. And again, the 2 and the I can't combine because one's a number, one's an imaginary number. They can't combine, so they have to stay separate as 2 plus or minus I. All right, here's one for you to try on your own. All right, solve this equation using complex or imaginary numbers. I'll show you the answer in 3, 2, 1. And the final answer is -5 plus or minus 2i. So we subtract 7 on both sides to get that squared by itself. Take the square roots, remembering the plus or minus, and that the square root of a negative now has that I. And lastly, subtracting 5 to get our final answer. All right, so now go ahead and practice. All right, so you want to practice simplifying the square roots of negatives using that I, and also solving equations that now you're taking the square root of a negative. All right, you just have an I in your final answer.